Time for another video. In the last few videos, we took care of a lot of the underlying plumbing. I think that info is very useful as a software developer, but I suppose it can be a little tedious. Hopefully what we do today will remind you that we indeed have a polls service and a polls repository, part of our polls feature. And these handle the application logic and storing data in the database, which is Redis if you forgot because it's been so long. One important piece of data for the poll is the participants belonging to a poll. We'll get to the point today where a user or participant is added to the poll in Redis upon connecting via WebSockets, and then they're removed when they either disconnect or send their own request to be disconnected. We'll actually handle the requesting to be disconnected later. In fact, that's probably one and the same as disconnecting, so I go back on that. We'll also deal with a concept in Socket.io and often more generally with WebSockets, which is called rooms. This is a way to make sure that data is only sent via WebSockets to users participating in a particular poll, and not to all of the WebSockets that may belong to a server. As always, I want to remind you that there is a repository for this course right here, and there are written tutorials in the tutorials folder written in Markdown, and there are some instructions for getting started. Let's go ahead and start by working with our polls repository, and then working our way up to the polls service, and then the polls gateway. Inside of this polls repository, you'll notice that we already have a method called addParticipant, which takes an object of type addParticipant data, which has a poll ID, user ID, and name in it. We used this addParticipant previously in conjunction with something in the polls controller, which was called a rejoin poll, which called the polls service rejoin poll, which then added this user back into a poll if they logged out. I don't think we're going to need this because of the way we're now going to handle connecting a user via WebSockets, but I'll leave this here just in case we need it when we're working on the React application. Back in the polls repository, let's now create a similar method for removing a participant. And this will be necessary when a client, a WebSockets client more specifically, inadvertently disconnects, or if they deliberately disconnect. So let's scroll down, I guess beneath this catch block and this outer block here, and we will add the following. This is an async method called removeParticipant. It doesn't take an object, it just takes a poll ID as a string and a user ID as a string. It's debatable whether you would want to pass an object just in case the interface or the arguments change. I'm happy with just using 2 arguments here. And this returns a promise of the entire poll or poll data. In here, we create the path to the participant that we want to remove. So the base path of a poll is at the poll's poll ID, and we'll kind of see this in Redis. So this is the main key we access the JSON object on, and the participants are going to be accessed by participants.userid. So this is kind of a way of mocking JSON inside of Redis. And mocking probably isn't the correct word, but we are using the Redis JSON module. And when we look at Redis, I'll remind you how that looks. Then we're inside of a try catch block, we're going to send a command called JSON delete to this participant path. So first you can put the key and then the path, and then we will return this.getPoll, which is a method we've already added. So if I scroll up somewhere in here, we have getPoll, here it is, which just takes a poll ID. And then instead of having a key and a path, it just gets the entire poll here and then calls Redis with a JSON get with the key. And then this period means like the root element inside of the poll. Back at removeParticipant, if there's any error, we'll just say that we failed to remove that user from the poll, and we'll throw our internal server error exception. In fact, that is a built-in NestJS exception. Now, while we're at it, I want to refactor the addParticipant method to use the existing getPoll. So this here is the addParticipant, and you can see we have some logic to send the command to get the poll. So basically, in this function, we add participants at a participant path, and then we basically duplicate the logic here to get the poll. So we're just actually going to replace this with, and in fact, let's get to the return statement. We're going to return this with this.getPoll poll ID. And if you need to take some time to review this method, go ahead and look at the code in the GitHub repository. There's one more thing I want to do while we're thinking about the actual shape of the poll that this repository is returning. I'm referring to this, and that is to add two variables that we'll be using that we have not yet added to the poll, or I should say two type fields. So one of them is this has started, and I probably should have called this like has voting started. So this basically means that all of the nominations have been submitted and the poll is started. Then the other one I want to make sure we have is this admin ID. Looks like we already have it. And this is what we're going to use to make sure that only an admin can forcibly remove someone from the poll down the line. And that's what we're actually going to work on in the next tutorial. Then back in the polls repository, you'll see we now have an error. Let's make sure we actually instantiate this has started field. So let's scroll up to where we create poll, and you can see here, we're returning a poll, but this initial poll is actually missing some of those fields, which should be the has started field. So let's scroll up, and in this initial poll block, initial, let's add a has started false. The next thing that we'll do is add service layer methods in the polls service here, and I actually did not save this polls type. And so let's scroll back up and open the poll service. But before we add these service methods, let's define the shape of these methods' expected arguments, which we'll define as add participant fields, because we'll be adding an add participant method, and remove participant fields. And we do this in types.ts. One thing I'll mention, when we were working on the polls repository, I just kind of clicked on this polls, or command clicked, and that actually had taken us to a poll types in this shared package. So go back to the setup of this repository. We're actually using npm workspaces. And the reason we put the poll types in the shared folder is the shape of the poll data on the client application will be very similar to the poll shape on the server. They kind of line up. So I made this little shared package. All right, but this types is actually in our polls folder of the server. We have a section here under this comment defining the service argument and return value types. I guess they're just arguments so far. And notice that we suffixed them all with fields. So at the bottom beneath rejoin poll fields, let's add participant fields, making sure to export it, and remove participants. Notice that when we add a poll, we give the name, user ID, and poll ID, which is basically the same as a lot of these fields. And you might want to like set rejoin poll fields equal to add participant fields if you know they're always going to match. I don't know that for sure, so I've created separate types. To remove a participant, you do not need their name. So back in the polls service, let's add the method to add a participant. So this method is pretty simple. We're basically just going to take that add participant as add participant fields, and let's import that. That's the one we just created. And it will return a promise of a poll, which, if you remember, is basically the same thing we're returning from the repository. So this is a very simple service method. I know it's annoying when we duplicate this, but I suppose it's better architecture just in case you change something or need to add some subsequent application logic. Remove participant will be a little more involved. And the way this works is first we get the poll, and we want to make sure that the poll hasn't started. Basically, the way this is going to work is once all the contestants or participants have entered the poll, I guess they're not competing, so if they're just participants, then I don't want to allow them to leave or enter the poll. They may lose their WebSocket connection and like disappear, but still I want them to be in the database as having participated. Then you might ask, how do we actually end the poll at the end of the day after everyone's voted and then someone disappeared? The admin or the person who started the poll will have the ability to say, okay, end this. I don't know what happened with my friend Jim. Anyhow, if the poll hasn't started, then we will update the poll by removing the participant, which is the method we created, which returns the poll. and we just return that. So I guess we could have just returned this statement here. And notice that if the poll has started, this doesn't return anything. It's just void and the poll does not change. One other thing I want to mention about returning the poll from the polls repository and from this service, meaning we're returning an entire poll. I previously only returned like the slice of the state of the poll related to participants, meaning I only returned participants when I called remove participant, and then I sent an event to clients which was called participant removed. Now I'm getting ahead of myself. We haven't made any events yet, but I decided that I just want to return the entire poll and send a message back to clients saying poll updated, and that's a common method that can be used across various gateway and service methods. The downside of this could be if you had a poll with tons of users and every time the poll's updated, the server sends this data to everyone, and perhaps that could be sending a lot of data over the server or over the internet, which you wouldn't want to do. I'm using this app for a small use case, so perhaps you could set the number of nominations or participants to limit that payload. That's just to say, if you were doing something that was a larger application, maybe you would only want to return a slice of the poll state. Let's now move on to our polls gateway, and maybe I'll close some of these editors. It's getting busy. And we're going to handle adding a user to the database and removing them upon connection and disconnection. But there's one thing that we have not yet discussed, and that is making sure that from a socket standpoint, that sockets connected to a certain poll only communicate with each other. And the way that we handle this in sockets, and specifically in Socket.io in this case, is via something called rooms. So let's handle adding the client to a particular room. Let's go up to our handleConnection method here. This has a lot of logs. I considered deleting some of them, but we're just going to leave them here, and hopefully you can make sense of them, or you can clean them up a little for your use case. We aren't going to be using this emit anymore, and here's what we will do. First of all, we're going to define the room name as the actual poll's ID. So the way that Socket.io will know which clients can talk to each other is via the room name, which is actually just the poll ID. So to join a room or have a socket join the room, we will do client.join. And one thing I want to mention is sometimes I name this socket and other times I name it client. That was kind of foolish. So this is an await method. So let's make our handleConnection asynchronous. It is by default, I believe, but let's just label it here. Joining the room is pretty self-explanatory, but actually how to get the size of the room is not so much. And you have to access the IO, and this .io was defined here with the @WebSocket server decorator. That's a way that NestJS gives us to access whatever our WebSocket server is. And in this case, we called it a namespace, which is like a subfield or class of the actual socket server, and that's because we gave this a namespace of polls. So this IO is not accessing the whole socket server, but this specific namespace. Anyhow, basically we have to access the adapter, get all of the rooms, get a room of the name, and then the size. Now, one thing I learned earlier is that I think if the room name becomes 0, like there are 0 clients, this get returns undefined. And so I think I was going to do this in the next tutorial. I only usually write one script at a time. I did 2, so I can get ready for the 4th of July. And so we'll just basically add this sort of null chaining here, and then use this question mark to default to 0. So basically, if get room name is undefined, we'll just return 0 connected clients for that room. Then we'll just add some logs saying that the user ID connected to such and such room name, and that such and such room name has so many connected clients. Let's add something similar in this handleDisconnect. And actually, before handling disconnect, we actually have to add the participant to the poll. We'll do that by calling that addParticipant method we just created, which accepts these fields. And remember, the poll ID, user ID, and name are added to the client via that sort of middleware we created inside of the Socket.io adapter, which extracts the JSON web token, and its payload, which has the poll ID, user ID, and name on it. But then what do we do with this updated poll? How do we send it to the clients? We do it by accessing the server namespace with this.io, and we say send it to a particular room name. And then to send an event in general, we do .emit. So if we wanted to emit to all the sockets, not just this room, we could get rid of this too. And then we emit the poll updated event, which is what we're going to call it. I probably should have stored these in constants, but I was lazy. And we're going to send the updated poll as the payload, which is how we do it, by passing it to emit as the second argument. One thing I want to mention is this here emit method. So there are a few ways to like emit or send different message names and payloads to various socket clients. The first way is with a socket itself. And if we look at our exception filter that we recently built, and so let's go to exceptions and let's go to the catch-all filter. You can see that here, if there is some sort of error or exception, we call socket.emit exception. Now this socket is the same thing as client in the polls gateway. That's what I mentioned earlier. I should have probably named this client. And this is emitting to the same socket that is trying to connect here. So if you do socket.emit, the message goes to the socket with the incoming message or data or connection. On top of that, when we use the server or IO to send a message, there are two ways. So the first is using io.emit, or it could be io.namespace.someroom emit, like in our case. This is going to send it to all connected clients or all connected clients belonging to a particular room. There is another way to do this though, and that is to send it to all other clients except the sender. So you would take the socket or the client as we often call it, and then append a .broadcast.emit, and that's a way to send to all other clients. But in our case, we want to send this to basically everyone connected to a room, which again is why we are using io to room name.emit and not like socket.broadcast. That was a lot of explanation, but some of it will be reused in disconnecting. I'm going to actually remove all of these logs since they were just used for us to like see while disconnecting from Postman. And I guess I'll get rid of this one too. We'll make this asynchronous. And then we'll actually extract the poll ID and user ID from the socket client. Then we'll reach out to update the poll by removing the participant. And remember, this one doesn't take an object, it just takes a poll ID and user ID. We get the room name again, we get the client count, and let's just do this now since I was going to do it in the next tutorial, where we basically will default to 0 if it's undefined or null, or if any of these two fields are undefined or null. We log that we disconnected. We then count the number of connected sockets, which actually this now is client count. You can see I copy and paste code sometimes before it's complete. And actually I was wrong. This should be sockets.size, but I accidentally deleted up here the sockets, which is this.io.sockets, which is all of the sockets which are connected. And then we just add some logs to say that certain socket was disconnected from the room. Then remember that updating the poll here could return void or a promise of void. So basically only if we get an updated poll are we going to emit that poll updated event. So I started our application with npm run start. Now I've set this up, but the first thing you want to do is in one of your socket.io clients, I have this test client 1, 2, and 3, is make sure that you go to events and make sure that you add an event called poll updated, because remember that is the event we expect to receive when the server updates the participants. And make sure you do that for all of your clients. Let's see, this one has poll updated. Make sure they have the token headers. I'll hide the auto-generated ones, and I'll check client 3. So now what I'm going to do is have all these socket clients open. So I have 1, 2, and 3, and I have create poll, which creates player 1. We look at the body, join poll, which creates 2, and join poll, which creates player 3. So let's create the poll. And then we'll have players 2 and 3 join, and note that the poll ID starts with 7KL. And join poll is probably a bad name. I should have done something like get token, because they haven't actually joined the poll. You see this poll has 0 participants, and that's because they're going to actually be added as a participant when they connect via WebSockets. So my naming could have been better. Now let's go here, and I'm going to connect, and let's maybe clear these messages with this client. And you can ignore this payload for now. This is from the next tutorial. So let's just connect. And they were forbidden. If I go to the headers, for some reason, no matter how many times I save this thing unchecks. So let me save it again, but let's connect. And this token, remember, is a variable that gets saved when we create the poll. All right, so they connect and you get poll updated. And you see that they are added as a participant, and this is their ID. Let's go to test client 2. Their token is indeed in the header, and let's connect. And you see they get poll updated. And it shows 2 participants. Sorry this is so hard to see and it's not zoomed well. It's really hard to fit Postman in a small screen with large font. I can't shrink this, so we have to live with it, I guess. Or I could go to some advanced settings, which I'm too lazy to do. Let's connect with socket 3. Make sure they have the header, make sure they're listening to poll updated, and we connect. And you see they get all 3 participants. Now, if we go to client 2, there's a new message, and they also got poll updated again with all 3 participants, and client 1 should have received it for participants 1 and 2, and then again for just itself. Or sorry, for participants 2 and 3 when they were added. I've now opened Redis Insight. Let's refresh, and you see that we have a poll. Maybe I can increase this font. We have a poll, which is the proper ID, and you can see the key is polls : and then the poll ID. And remember, we added participants by using .participants and then their participant ID, which basically adds them to like a JavaScript object. So you basically map their user or participant ID to their name. So these are all here, and we can see that the admin has this ID 7BD, which is player 1, and that will become important next time, and the poll has not started. Let's disconnect some clients and see what happens. Let's first disconnect client 3. Now, they only get a message basically saying they disconnected, but if we go to client 2 and click new messages, you see they get poll updated, and it only shows the first 2 players are left. And if we disconnect this one, hopefully we get a message in client 1 showing that they are the only person left. And that's the case. And if we go to Redis Insight and refresh, hopefully we see that only player 1 is left. I hope this is starting to come together and look like something real. I know we've been building a lot of the infrastructure, but I think this is cool, and if you stick with it, it's worthwhile. In the next tutorial, we're going to add an event for forcibly removing, or you might say ejecting, a participant. And so that is like if an admin wants to get rid of someone before the poll actually begins. And so some of the logic will be similar. We'll reuse the remove participant service method, but we'll want to restrict this functionality to the admin or the person who created the poll. See you then.